There is a procedures in Houdini that doesn't seem too fancy at the start, but it can be perfect building block for something more complex. And basically, depending on the quality of your little actions and little tools, you can get much more sophisticated and cool result. So today we will go over creating random variation in the segment length of some curves while keeping its shape. Let me go over the setup. In this case, it's super simple, and this is just for testing purposes, just for us to see what we will get at the end. So I have a line with some segments on it. I have copied this line a couple of times. I've added curve node. So if we look at the primitive indices, for now, as you can see, each curve has its own primitive number. But after curve node, I have each segment as a separate primitive also. I've achieved this using the breakpoints mode of this node, and I've enabled the cut at all internal U breakpoints, and I've set first U and second U to 0 and 1. These have given me the separated segments. Then I've resampled it to have some resolution and points to work with, and then did something that we already did on this channel in the wires lesson. Basically, I've randomized the gravity for each segment, but it still looks boring because they are all perfectly even. So let's handle this issue. Today we will go over two ways of achieving that. It is not the complete list, but it's definitely interesting ways of achieving so. Let's start with the one that will require less vex code, but not that versatile and flexible. I will start with selecting the first and the last point of each primitive here. I will create group expression. I will set it to points. I will call the group ends. And in this field, we will type some kind of condition that will help us decide if this point belongs to this group name. Today we will use the new way of getting the first and the last point of each curve, which in my opinion is one of the most stable and robust ways of doing so. We will check if current ptnum is equal prim points from zero geometry and from current primitive to which this point belongs. And just to clarify, prim points function will return all points that belong to this particular primitive. And I will need to get the last element of the array that will be returned by this prim points function. So we will get array for each unique primitive number here. And if current pt number equals one of these values, because we have a multiple primitives, then we will append this point to the ends group. Hopefully it makes sense. And what's great about this particular way is that we working per primitive. So let me just quickly demonstrate. For example, if I will set ptnum equals numpt minus 1, so the last possible index, we will get only 1 point on the last primitive, which is not always the best solution. And the same we will do with the first point. So here we will copy this expression, we will just paste it, and now the index that we need is 0. So that way we have selected the first and the last point for each primitive. So this is nice. We need to isolate these points using blast. So I set group type to points and group to ends, and I will set it to delete non-selected. Then we will need to use scatter node. We will choose, for example, density for this. And also we will make scatter node output source prim UV attribute, which will contain the parametric UV coordinate of the source geometry. And that way we can reference initial coordinates on this geometry. Now we're interested only in X component of this attribute because we have only lines, only polylines, which is essentially one-dimensional thing. So we have this scatter, we have source prim UV, and let's start with doing so in one line to clearly illustrate the concept. And I also need to get the same attribute for these points. So let's use ray node. Let's fit initial geometry to the second input, and the isolated points to the first. We will disable transform points and we will only use prim UVW attribute, and we will call it the same way as we call it in the scatter node. Then we will merge this. Then we will use sort. I will get rid of any geometry here, leave only points. Sort would be based on the attribute source prim UV. And I think there is a problem with this thing. Yes, because we need to set ray to minimum distance independent of normals. Now we should have correct distribution. Nice. We can, for example, get rid of points that too close to each other, and then we will just need to add, and in polygon we will connect these points by group. And to do so for each of these primitives, we need to use for each primitive block. We will go here, we will reconnect this to for each begin, and add, we will connect to the for each end. Of course, we need to vary seed for each primitive, so we will create meta import node. In the scatter node, we will create spare input. We will reference the metadata node here, and in global seed, we will type detail -1 as usual, iteration 0. And now we have random seed for each primitive. Or instead of using the meta import node, we can control seed for each primitive externally. We can just create, for example, attribute randomize, create only one-dimensional value, set attribute class to primitives, and let's set maximum value to something really big. And in scatter node, instead of using this, we can use, and we can control it from here, which is also convenient. So the second way is a bit more involved, and it will require us to use attribute wrangle node. We will set it to primitives, and the good thing about this setup is the fact that we no longer need that much nodes, and it will give us more control, but we will have to type some code, which is actually not scary. And we will introduce a couple of concepts, first of which is concept of a function, which is basically a reusable piece of code, kinda node in the code world. So it will have also some inputs and it will have some outputs. But it's not mandatory actually to have some inputs and even to have outputs also. But to simplify things, we will think of it as a kinda node. Let's start with initializing our function, and it will start with keyword function. It's not mandatory. It will help us to distinguish the function inside of our code. Then we need to set the type of the function, the value that it will return. In our case, it's integer. It could be float, vector, array of floats, vectors, string, or it could be void, which means it would not return anything. In our case, it would be integer, and we call this function prim from array. Then we need to define inputs for this function. Function has its own scope, which means it doesn't know anything about what's outside. So you have to explicitly set inputs on this function. I mean, in our case, this function doesn't know anything about primnum attribute. So we will have to explicitly set it. So first input would be primnum. Second input would be an array of float values, and we will call it cores. And to tell Houdini that it would be array, we need to use square brackets at the end. Then we need to create a body of function. I mean the code that would be executed. Open and close curly braces. And inside of this, start with defining our first variable inside of this function. It would be prim, and it would be just empty primitive. So to add empty primitive, we just need to use function called addPrim. First input, as usual, would be the index of geometry, and in our case it would be 0, and in case of addPrim, addPoint, or addVertex, it always would be 0. And the second argument would be the type of primitive this function would create, and it could be poly, which means closed polygon, or polyline, which means opened polygon or curve. In our case, we will use this one. Don't forget to set semicolon at the end of each line. Then we will initialize two more variables, first of which would be empty variable for now position, and second one would be index of newly created point. What we need to do next is to iterate over each value in this array. So let's say we have an array of 0, 0.1, 0.5, 0.8, and 1. And we need to grab each of these figures and iterate over them. To do so, we will use for each block, for each keyword, and then we will need to use the element itself. We need to initialize it. So it would be float and it would be called coord, and the array from which we will extract this element on each iteration would be coords, which would be this array. We also can tell for each block to return current iteration index by simply adding the integer I or n, usually it's I, at the start of our inputs or our for each. And then inside of this for each block, we will get position of newly created point. It would be prim_uv from 0 input. We will get position and we will sample this primitive number here. So it would be prim_num. And as a parametric UV coordinate, we will use some value from this array. We will use this particular variable. It would be coord. Then we need to create PT and we need to store its index in variable PT. So we will add point just in case, because we might have to set some attributes in this point or something like this. It would be useful. So now we have our point. Now we need to append it to new primitive. So we will add vertex to 0 input. Primitive to which we will add our vertex would be prim that we have initialized at the start of our function body. And the point that we need to attach to this primitive would be PT. And at the end, don't forget to return the index of our primitive, because we have stated that function would be integer. For now, this function doesn't do anything because we haven't called it yet. Let's start with getting the array of float values from 0 to 1. I will start with simple array consists of two values, and to initialize it, you can use array function, and wherever you have in the arguments here would be appended to this array, which is convenient. Keep in mind that this one is float array. Then we need to define amount of points in this array. So I will create integer called iters, and it would be equal channel integer called iters. Then I will do something pretty cool. I will resample this array using function called resample linear, and the first argument of this function would be coords, so array I'm about to resample. And the second one would be the new length of this array, so it would be iters. I can look at this value, so I will create a float attribute, float array attribute. We will call it coords, and we will make it equal coords array. So just to see what will happen, I will create the sliders here. And let's go and look at these arrays that now got recorded to our primitives. And as you can see, as I increase my value, for now iterations is 5, which means the new length of array would be 5, and it's interpolating between these two values from 0 to 1. So that way we can easily generate any amount of values between these two. So we don't need this attribute anymore, and let's move on. Next, I need to calculate the unit, and by unit I mean the relative distance between 2 points. So because we have value from 0 to 1, I need to get the length, the relative length of the segment. To do so, we will create a float variable. We will call it unit, and it would be equal 1.0 to state explicitly that this is float divided by iters, number of iterations minus 1, because of the fact that elements in array start with 0. Then I will create a seed attribute because it's useful to have one. And then I will generate some kind of random value. We will call it random amount, and it would be equal channel float called random amount. Next, I will iterate over each element of this chords array. So I will use for each again, and I will use the same form. I will start with getting current iteration index, then I will get the item itself. It would be float, it would be chord, and the array from which I will get this item would be chords, the one that we have generated. And the value would be equal current chord plus some random value from current iteration. As a seed, we will use seed. And I will override the existing value of chords array of particular element of this array. So this expression here means that I will get element number I from this array, and I will set it to my value. Let's use our function prim from array. So first input, as we stated before, would be primitive number, which would be prim num with @. The array would be the chords array. Because of the fact that we no longer need initial primitive, we will remove it. We will use remove prim function, and it accepts 3 inputs, first of which is geometry, as usual. Second one would be the primitive num, so the primitive we are about to remove. And the third value will decide if we need to delete the points that was on the removed primitive. So 0 would be we will leave these points, and 1, which is one that we will use, would mean that we need to delete these points. So let's see what we get right now. We still have the same shape. We can, for example, add here a circle just to observe what will happen. We will make it open arc, and we will plug it instead of our curve. So right away we see that it's doing something, but it's actually doing something weird. And as you can see, our geometry is all over the place. We have lost our point numbers, and we need to fix that. And the first step to fix that would be to sort our array before it goes here. So to sort our array based on the values inside of it, we can set it to sorted version of itself. So it would be sort, and the array would be chords. And it's gotten better. As you can see, we no longer have these broken values, which is good. I need to have my first and the last point of the circle intact. I need to have it untouched. We will set the first point of this array, which would be index 0 to 0, and the last one. And by the way, nice way of getting the last element of array is to have -1 index, so it will count it from different end, and we will set it to 1. And now we have 2 points that stay in place no matter what seed or what values we have. To me, this values is too wild, and we have created this random amount variable. Let's utilize it, and let's also remap our random. So it would be fit 0,1 from -0,5 to 0,5 to have the random values go into both directions. And we will multiply this value to random amount. So it's better. And as you can see, it's pretty magical when we have our points basically shuffling, but we still have our point indices intact. Just a quality of life thing. I can multiply this value by unit, which means from the values of random amount from 0 to 1, I will be limited to the segment length, which is really convenient. And as you can see, I can resample my value. And as you can see, I can resample my initial curve in a different way, and my shape would stay the same. And I can go beyond the 1 if I want, but generally I will try to stay inside of maximum segment length in this case. So now we have our random, but we also can give it even more control by sending this value to tramp, because it's still from 0 to 1. So tramp, and we will call it, for example, remap. Let's create this ramp. And now, in addition to our random amount, we also have distribution along the curve. So we can decide overall shape of this thing, which could be extremely useful in a lot of different occasions. And now we have like really good control. One thing though that I wanted to add also, I need to have random values for each primitive, and it's pretty easy to achieve. I will add primitive number to the seed, and now we have slightly different values for each primitive, as you can see, which is exactly what we needed. And instead of this setup, we can simply use only one node, and we will get essentially the same or even cooler result. We can add a lot of additional controls, one of which could be, for example, instead of using explicitly the number of iterations, we can set, for example, target size, like in resample node. Let's create this variable, and we will need to measure the curve. We will need perimeter, and the iterations would be equal the perimeter divided by target size, and we need to round it using round integer function, rint, and we also need to explicitly convert it to integer using this keyword as a function. Also, we can apply some safety measures, and we will clamp this target size. So clamp, as an input, we will use target size, again, itself, from, let's say, 0.05 to no matter what. We need only a minimum value. And now when we create target size variable, you can see we already clamped it. And now we have something like a resample. So I can decrease random amount. And as you can see, as I increase this, I have more or less segments. And if I decide to make it larger, it would act as a resample node. So we did quite a lot of stuff in only 34 lines of code, thanks to the fact that we have reused this code a couple of times. We can also decide which one of the modes we should use here simply by adding if block. So if, for example, channel integer resampled by target equals 1, and now we can switch between two modes. One mode would control our iterations explicitly, and second one would control it using the target size. We can go to edit parameter interface, change this one to the toggle because it only has two values, 0 or 1. And that way we have given ourselves additional layer of control. And of course you can do a lot of stuff with this one. So to conclude, you don't have to be able to write Vex code, but it's definitely additional tool at your disposal. Vex is one of the simplest programming languages out there. We did quite a advanced stuff here, but it's really convenient and it's simple if you break it down on the elements. And I don't say that this is 100% better than using nodes. Both options give us pretty cool results with different vibes. This one can be controlled in a slightly different way. We can, for example, adjust relax iterations. We can adjust scale. We can do a lot of stuff, actually. We can control density scale. We can add additional attribute to control density. So a lot of useful things that we can do. And this one gives us more precise control. This one is also easily extensible, but it gives us slightly different type of control. And both of them definitely could be useful in different situations. So yep, thank you for watching. See you in the next video. Bye.